Today is the 1st of November, 2014, and this is episode 158. This show is intended for informational and educational purposes only. What cryptocurrency enables is new, empowering, and exciting, but we're not experts, just obsessed companions walking the road towards a more peer-to-peer future.
Welcome to Let's Talk Bitcoin. I'm Stephanie, and I have a very, very special guest with me today. It's Kevin McKernan. Kevin, first of all, welcome to the show. Thank you for being here with me today.
Thank you for having me. It's a real honor. I've been listening to the show diligently for a good year.
Very cool. Just to warn you, listeners at home, this interview is maybe going to take a little bit of background explanation, but we swear it does relate to Bitcoin, and it also relates to something that's been in the news a lot lately, which is Ebola virus. Now, what is the connection between Bitcoin and Ebola? We'll find out here in moments, but first I just want to tell you a little bit more about Kevin. Kevin is the Chief Scientific Officer at Cortigen Life Sciences, and they do genomic sequencing. Specifically, they're diagnosing rare genetic diseases, often in children. He's also worked on the Human Genome Project before this, and his company Medicinal Genomics was the first to sequence the cannabis indica and sativa genomes. That's a very cool claim to fame in the scientific world. And also he's got some published work, not only on genomic sequencing, of course, lots of copious publications, but also on intellectual property and some of the problems that poses to scientific progress. He's also interested in Bitcoin. So we're going to tie all of these things together. But Kevin, first of all, did I get everything right?
Brilliantly, yes. Thank you. Very kind introduction.
Excellent, excellent. So, and also, listeners of Let's Talk Bitcoin may not know this because it actually hasn't really come up in detail in the show, even though, geez, it's been 160-something episodes. I actually have a PhD in biochemistry. I studied Alzheimer's disease and specifically how cholesterol metabolism in the brain relates to Alzheimer's disease and how maybe new treatments could be gleaned or created from that. So my scientific background is going to tie into what Kevin's doing here, his Ebola virus project. I also went to medical school for a couple of years, so I'm familiar with the clinical stuff too. Just wanted to let people know about our backgrounds and how they coincide. I've actually known Kevin for a while. In other circles, it's like this weird kind of worlds colliding thing. Being in science for a while, I actually can't say that I've really met a lot of scientists who are true outside-the-box thinkers and who really question and are deeply curious about all kinds of stuff outside of just science, maybe some of the social norms of government and things like that. And Kevin, you are one of the rare few. So thank you very much for that.
Oh, thank you. Yes, I did have... I guess in the sciences, you would argue I'm probably unschooled. I didn't get my PhD. I dropped out and decided to just keep focusing on what the market wanted. And that, I think, has changed my perspective quite a bit.
Yeah, for sure. You've had a really successful career, and it's amazing you don't have a PhD, but you don't need one, clearly.
Yes. No, there is some selective pressure against it, but I actually think it opens up your thinking if you're not in that system. It does indoctrinate you a little bit into an authority structure.
Absolutely. I can vouch for that. So, okay, let's get into the project that you're currently working on. Or actually, before we do that, maybe we should talk a little bit about just intellectual property and the peer review process and why science is broken.
I'm going to lead in on this, and anyone who looks at my background has every right to throw the Hippocratic rotten vegetables at me, because my history is loaded with patenting and loaded with publishing and using the peer review process. But after I've been through that for numbers of years, even having gone to court fighting patents, I've come to recognize that the system doesn't work. The system's actually designed to do the opposite, maybe not intentionally, but it just has the opposite effect of what it's intended for, and that it holds back information under the fallacy that it's needed to incentivize people to invent. And that's just not true. Invention happens through the crux of problems, presenting opportunities to people. And there does not need to be a carrot from the government hanging out there to make it happen. That's what's told to everyone to justify the patent system. But it actually, in the end, creates a tremendous amount of money being spent on legal fees assessing freedom, whether you're allowed to do anything, whether you have to ask permission to do a business. And that is really tough to swallow when you're dealing with healthcare. When patents start getting in front of children getting access to medicine, it's a really tough nut to swallow. And so when you dig into it, you can clearly see the work from Stephen Kinsella is great on this, is that this is a really heinous system of control.
This is your field. Like, that's what you do. You diagnose children with rare genetic diseases, and you see all the time children who can't get access to perhaps experimental medications that may help them, but we don't know because the IP and the patents are getting in the way of being able to access those medications.
It's very hard to justify in your head. We seem to be very complacent in minimal data to take a life, but require extraordinary data to save one. We can see this in the way that our government just spends money. So for every $4,200 of taxes collected, $1 goes to the NIH. Probably half of that money goes to the DoD or military adventures overseas.
And just for our international listeners, the NIH is the National Institutes of Health, which is government-funded scientific and medical research. And the DoD is the Department of Defense. Ironically named, it's more like the Department of Offense. This basically is the organization that handles all the wars.
Yes. So that gives you a bit of a distrust in utilizing that mechanism to drive research for something like Ebola virus, because that mechanism is unlikely to change very quickly. By definition, it has a 4-year period of listening to its representatives, or its voter base. Yet its frequency of listening to us via the NSA is much higher frequency than that. I see that all as a pagan ritual that's meant to placate the masses, but I think many more people are starting to wake up to the fact that this doesn't look like it's going in the right direction.
I'm curious, what does this have to do with the genetic disease called Niemann-Pick type C disease?
The precipitating event here was my 13-year-old son asked me he got halfway through watching Contagion last week and asked me to sit down and watch it with him. That, of course, created a flurry of questions, which I tried to, in sort of an Aikido move, redirect toward empowerment. Let's ask questions about this. Let's Google your questions. Let's see what kind of literature we can pull up on the infectability of Ebola and all of these things. We figured our Google's as good as theirs, but the reality is it's not. When you start digging into papers about Niemann-Pick, you find that a lot of them are behind paywalls. Another intellectual property artifact of the copyright system. That the case is even more true with Ebola research because more Ebola research is government funded. That's a double entendre in that if it's government funded research, why is the research behind a paywall when all is said and done?
You're forced to pay for it, but you can't look at the results, basically.
Right. Yeah. So
just to stop down here for a minute, the connection between these things that seem maybe a little bit disparate. On one hand, we've mentioned paywalls. We've also mentioned this disease, Niemann-Pick type C disease, and we've mentioned Ebola. The connection is this disease, Niemann-Pick type C disease, is caused by a genetic defect in a protein called NPC1, or Niemann-Pick type C protein 1. There are actually children who have this disease because they've got a defective gene. What it does is it's a cholesterol transport protein in the cell. And so if they have this defect in the gene, they accumulate cholesterol in their cells and it causes all kinds of problems, seizures, and their liver and spleen get enlarged and just makes life really miserable. And it's a genetic disease, so there's little you can really do about it. The connection to Ebola virus is that actually the Ebola virus requires this protein, NPC1, to enter the cell. So Ebola virus basically has to hitchhike into the cell on this protein, NPC1, in order to infect somebody. And there's been some research in the past that has shown that people who have mutations in this protein, NPC1, they don't have the full-blown genetic disease because they've got maybe one good copy and one bad copy of this gene. But people who have mutations are resistant to infection by filoviruses like Ebola, and that's just a family of viruses. So viruses that use this protein to get into the cell, if you've got a mutation in the protein, you're resistant to infection.
Indeed. And so one of the motivations for us building this website and this fund drive with Bitcoin to study this is that we don't know how this translates from mice to human because it's difficult to do research with Ebola on humans for good reasons. All of these studies have been done so far in mice. So people who have 2 copies that are knocked out have a disease, And people who have one copy that are knocked out are resistant to Ebola. This is very similar to malaria, also to an African sleeping sickness, where there is a heterozygous or one copy of a gene that provides resistance to an epidemic, and two copies cause a disease. And usually when this happens, it implies that this disease may not be new. It may have actually been around, co-evolving with humans for a much longer time than we've led to believe. But it also means that we need to know more about it. We need to know the frequency of those variants throughout all of the human population if we want to predict the pandemic. Resistance genes are incredibly important in graphing out those the spread of this thing.
But it's hard to access that information because it's behind a paywall.
Right.
So what you're doing is you've got this project going to open source that information so that hopefully we can get the information about genetic variants of this protein NPC1 in the human population so that research on Ebola virus can be moved forward and we can figure out who's resistant, maybe how long has this virus been around, has it been co-evolving with humans, what are some treatments that we could potentially glean from this. All kinds of other new discoveries could potentially be opened up if this information were easier to access.
That's right. So the point of the Bitcoin fund drive is really to be sort of an open source survey of, okay, who believes this information should be put public? And in the course of collecting that, if you want to call it a vote, I hate to use that word, but let's call it a survey. If it's collecting information as to whether or not you believe it should be put public, send us a Satoshi, whatever amount that you want. We will record the number of addresses that agree with this and present that to the journal saying, look, we've collected X number of addresses that believe that these things should be put forward. You guys should reconsider your policy on these particular endemic or pandemic literature related to disease. And we've also put another option in there for people who believe that's too coercive and are sympathetic to the business models of these journals, because after all, they didn't invent copyright. They're just forced to use it. You can send it to a different address. There'll be two addresses. One that will imply the Satoshis or Bitcoins will go to research, and the other that would ingest it or suggest it should go to the journals to offset any of the damages that they see from putting these things public. And the choice is up to the market. It's not ours. And I feel like that's the best and least coercive thing to do, is to see what the market thinks about this, let it react. And the reason for there being not just a collection of pure addresses is that it's probably not too hard for someone to come up with a Python script that can just auto-generate addresses and send 10 million Satoshis and have only really contributed $40. And the point is to present both of those statistics to the journals. Look, here's the type of money that was raised, and here's the number of addresses that were involved. They can get a two-dimensional sense of the outrage.
Oh my God, I'm just picturing it now. So scientists love graphs and charts, and you have the data, right? Like this voting system where there's a public record on the blockchain that there's your data of how many people or how many different Bitcoin addresses sent Bitcoins to each of these addresses. And it's like a vote.
Right. And the proceeds that are generated from this, whether they be Satoshis or the generosity of full Bitcoins, we are going to transparently and hopefully frictionlessly redirect to the research that's described on that website. And it's research that's meant to help fund the two labs that are specialists in genetic variants in the virus and genetic variants in the human population to understand resistance to the virus. Because we think those are the two avenues that need the most funding right now.
You are actually using multi-signature Bitcoin addresses to increase the levels of transparency and safety of storing these Bitcoin funds, right? Because I know you were kind of concerned that if you just had a single key address, it might lead to becoming a target for thefts or whatever, right?
Indeed. I use blockchain.info and Coinbase, and I know all of the limitations that those may have by leaving any type of key that's attached to the grid. So in doing this, I realized that this is somebody else's money. I actually, ironically, paid more attention to using other people's money than my own, and decided to go full-blown into making sure I generated addresses that were completely off the grid, that are in cold wallets, that have multi-sig on them, so that I'm not the sole steward of this. I also believe that when doing multi-sig, you shouldn't have one other person be the signatory because they can extort you when the money needs to move. You should have several and not all of them be required.
And so who are going to be the other key holders? Are they people that are also on the project or other scientists?
I'm debating on how public I should be with who they are. And so I don't know that I want to put that out there right now because I don't want them to be coerced either.
Gotcha.
But yes, there are people I know.
Okay, excellent. So people can also donate with dollars to this project, is that right?
There is a PayPal button down there, but I put warning around PayPal using credit cards, and credit cards are probably the least secure form of financial transaction available today. And I don't have the ability to do multi-sig on PayPal. I don't have the ability to redirect or collect data in two dimensions, such as, do you want the money to go to the journals or do you want the money to go to the researchers? But I do recognize that PayPal is probably touching more people right now. We have it there just to try and capture more audience. All of that right now is getting directed to the researchers.
It's really interesting to compare these two methods of collecting payments. On one hand, you've got the Bitcoin, which provides this level of security and also the ability to count sort of like how many people have donated and the public record of who's donated, or how many people at least have donated. With PayPal, it's all kind of proprietary, right? Like you have that information, you can maybe report the data if you want to, but it's a pain in the ass to get it, and you gotta extract it from your personal records. And you don't have the ability to route these two different campaigns like you do with Bitcoin. So just the contrast is really interesting.
Indeed, hopefully. And I believe, if I've been listening to your show correctly, there is some collaboration going on with Bitcoin and PayPal. So maybe this will be an impetus to move that along faster.
Yeah, there is. It's been really short on details. I don't know what form that's going to take, but it's not ready yet. So I guess we got to make do with what we got for now. Let's talk a little bit more about journals. Why do they put scientific information that's supposed to be mostly funded by the government, and so in a way, quote, everybody pays for it? Why do they put that behind a paywall so that you can't access it unless you're at maybe an academic institution that has a subscription to that journal?
I can't explain why, other than I know these business models like Elsevier and others have grown up over time to be publishers of this data. And many of the business models started when everything was in print. And the cost of publication was significant, such that they needed to defray the cost of printing things on paper and mailing it out to mailing lists. So I think it's really legacy. And what's happening today with the digitization of all this is there are many more open source journals that are emerging. And they also have some payment fees to manage the peer review process. But I still think the system needs a larger overhaul. It really needs to be a more open peer review process. I think what you would find in a more open peer review process. So just for the listeners to know, when you submit an article to a journal and they send it out to peer review, you don't know who they send it to. It's usually an anonymous peer review. They send back some comments and criticisms about the work. You try to address them, but in the end, if the editor believes the reviewers are right and you're wrong, none of that gets published. Their reviews don't get published, and you have to try again, modify and send it to another journal. This can take 6 months. I had one paper take 142 days in review.
Oh, it's common. I mean, I've seen papers take years. It's multiple rounds of review sometimes. Sometimes the reviewers disagree with one another. Sometimes your scientific work is going to your, quote, competitors, right? People who are finding out about your work before it gets published, and that might be sensitive information that might impact what they do with their laboratory. And they're all anonymous, as you said.
Yeah, they can torpedo your work while reading it and then go on and scoop you on the publication. It needs to be open. What we would advocate is that the reviewers actually have to put their name on it and put it public so that everyone sees what the review was and everyone sees what they had to say. And I think what you'd find is that would really change people's behavior in the process. Things would get reviewed more fairly. They'd probably be reviewed more quickly, too, because you could put a timestamp on them. I think you can also put a reward. I don't think there's anything wrong with saying we're going to reward you for your time. Everyone's time is valuable. But if you don't get the review done in a certain time, the reward's off the table. And this would probably get people to put, I think, a much more honest process in place.
You know what would also be helpful? To be able to read the comments of the reviewers that were attached to, like once a paper gets published, what did the first draft of that paper look like before it got to the reviewers? Did the reviewers add anything substantial that improved the work? Or did they just kind of nitpick? Or did they make criticisms that showed they didn't understand it? It would be great to be able to read and to see that process of peer review transparently.
Yeah. It's incredibly valuable information to see because it points to you the parts of the paper that are controversial and you pay more attention to those. And we've tried to do that with the website that we put forward. We know that time is really of the essence here, considering the spread of the virus, but we have circulated this amongst various researchers. Some have contributed some review anonymously, and some have been completely open. And we've tried to incorporate that in real time onto the website, saying, okay, such and such a person showed us that there's actually some seropositive asymptomatic patients of Ebola. What seropositive means is that they've been exposed to the virus, but they never got a fever. And the frequency of that is really high, actually, and that's very surprising. It's so high that we don't believe Niemann-Pick alone can be responsible for it, because what we know about the frequency of that gene in the population, what we know with the limited data we have today, is that it's not that high, at least in Northern European populations. And there's some data on it in African populations, but not nearly enough. So that's always been very helpful to get that type of feedback and just incorporate it instantaneously and be able to put in the person's name who provided it. It really creates, I think, a rapid response to something like this.
Yeah, it's always really valuable to pick out those weird cases that are like puzzling and to study them more closely. It's not just with Ebola that you get this either. I remember with HIV, there's a genetic variant of another receptor that the virus uses to enter cells, where some people who have mutations in this receptor are actually resistant to infection by HIV. There are a lot of genetic variants that do provide resistance to certain types of infections, and knowing more about them can only benefit us as humanity in being able to protect ourselves against these viruses.
There's a great story about a family in Nevada called the Hempel family who have twins with Niemann-Pick, and they've been donating the cells from the family to a variety of different institutions to study this, and they've been studying it for a few years. Some of that literature implies HIV may also require some interaction with Niemann-Pick. It has an impact in not just Ebola, and many viruses that try and get into the cell go through this transport, and it just seems like it's time to know more about it. If we can't get the focus through the traditional channels, let's try and create new ones. Let's create channels of getting money to appropriate research through the market and let the market decide. And I don't suggest that the website we have here is the only way. We hope that so people can copy and paste this idea to 100 to 1,000 different research ideas and see if we can pull off funding through market-directed initiatives.
I just love that idea. Unfortunately, I'm a little skeptical that most scientists would be open to doing something like this. As I said, you're one of the few truly outside-the-box thinkers that I know in science, which is one of the reasons why I don't work in science anymore. But I'm encouraged to see the model that you're doing, Kevin. It's really unique, and I hope that other people pick up the ball and run with it. I really do.
I think there's a lot of parallels to human biology with the blockchain. And this is why I've been paying a lot of attention to it, is that when you look at like the human genome in and of itself, we don't have one master cell that commands the other 330 million cells, right? Every cell has a copy of the entire genome, and it can execute any part of it. And every cell in the body you can actually take and reprogram into a pluripotent stem cell. What that means is a cell that can then turn into any other cell. So you could take a skin cell and coach it into a heart cell or into a brain cell. So every single cell in the body has the full program of its capabilities carried out with it. It's a highly distributable system. It's very analogous to a blockchain architecture. And when you think about human biology in that way, you stop and ask, what's the right way to research human biology? Is it through a top-down 12 reviewers reviewing these grants? And those 12 reviewers, they're smart as hell, but do they have all the information? Could they possibly have all the information? They can't. The market has more information. And so we have to consider ways of letting the free market weigh in on science, because it has more sensors on the microenvironment of the problems it's dealing with than any 12 people in a review committee can ever have. It's just an information theory problem that it's clear we have to find ways to decentralize research. Otherwise, it's going to always go through this intellectual bottleneck and suffer.
Yeah, very well put. I love that parallel of the blockchain to being like the genome. I'd never really thought about it that way, but it makes total sense. Let's get a little bit meta here. I mean, what do you see as some uses for blockchain technology in biomedical science? Let's make some connections here.
Well, I've always thought we could do some form of peer review on it, like we just mentioned. That would allow more real-time study of people's work. I mean, I think the really healthy thing we have going in the blockchain, in the Bitcoin community, is that it is so open and transparent that you can post something like this, and if there's a hole in what we're trying to do here, someone's going to step forward pretty quickly and show up. And it really does open up to more minds on any given problem. I think there's going to be ways to utilize this, not just in fundraising, but there are probably distributed computing problems that we could be solving. I think we've seen some folding coins happen.
Yeah, there is that folding coin project.
I would love to see a derivative of that where instead of just folding proteins, we're folding proteins that have certain variants in them that are quite damaging in the population that are being discovered by all of the clinical sequencing laboratories that are out there. We are discovering a vast array of new variants in the genome that we don't know what they clinically do. And they happen to be in patients that are sick, but we get a variant and we've never seen it before, and we would love to put it into a folding algorithm to find out, is it possible that this thing is pathogenic or not? But we just don't know. We're just collecting them. That's a wide open area. I think that could turn into something. And I think there's also an area for digital medical records. Right now, our medical records are just scattered all over the place, and they're with systems that are centralized. They're going to get hacked. And half the time when you call for them, they don't have them.
Yeah, that's a big problem. It's like you can't access your own biological data, your own medical records. But of course, government people can access your medical records, right? Because they're stored in these centralized databases. That's basically the whole point of HIPAA, which is the law that governs medical record privacy. It's like basically intended to kind of keep you out of your own medical data, but let researchers in that are associated with the government. It's a real problem. I love that idea of using blockchain technology for distributed, decentralized storage of biological data. And maybe, there's some way to use encryption and combine it with that so that you could maybe invite people in, like your doctor or someone you trust or who you want to see your medical data, and you would have control over who sees your personal medical blockchain.
Whether it be made safe or storage, or I haven't really kept up on who's most pressing the market on that front, but that's effectively a BitTorrent that's encrypted and shattered all over the internet. That's perfect for this type of problem.
Exactly.
And it gives you the keys so that you can share it with whoever needs. Right now, the keys are always in someone else's hands, and they're usually losing your data. The permanence there is a problem. We don't really know if they're going to maintain these servers at each university and each hospital. And of course, the sharing is incredibly complicated. And we even have some laws right now that are being put in place by the FDA that don't allow us to sequence people's DNA. So everything we do at Corrigan, we have to have a doctor write the prescription for the test. If you want to get sequenced through us, sorry, we can't do it. We can't sequence your DNA. You're not allowed to read your own DNA because you might hurt yourself, apparently. And so we have to have a physician involved in that picture. I think that's going to go away eventually just through blockchain technologies as well. I mean, if you put a server on some sort of .bit address, that's very difficult to shut down, then there's no place for the FDA to go and shut down. They recently shut down 23andMe for doing this.
Yes.
And that's been I think it's been a real crime, just because 23andMe has taught so many people about their DNA and gotten them about 750,000 people, actually. No one's been hurt as far as we can tell. And they got people like Sergey Brin involved because he has some Parkinson risk now, and he's funding a lot of Parkinson research.
Because he realized through 23andMe that he had the risk. That's
right. So there's a seen and an unseen here. The knee-jerk reaction is you're too ignorant to understand yourself, so we're going to take control of that. That's a real shame, I think. It doesn't leverage getting everybody involved. And the reason I brought up this family from Nevada is because these were folks that had some experience at Netscape, but in other words, didn't really have any molecular biology background. But they find out their daughters have this disease. They drop what they're doing, and within a matter of a couple years, they got their own drug called cyclodextrin through the FDA. I mean, that's a Herculean task that some researchers can't even accomplish in their entire lives.
Yeah.
And they did this because they were so motivated. And that's the story, I think, of individuality, is no one's going to care more about themselves than you. And when you find out you have a disease, you're going to become an expert in it pretty quick. You should hear the conversations these folks can have with physicians. You would think they have MD PhDs.
They know the literature better than a lot of people in the field. It's amazing.
Right. It is. And so I think it is a great disservice to make the assumption that people are too foolish and aren't motivated to learn this stuff, I think you'll be quite surprised how motivated people get when they realize it's about their own health.
I love talking about those inspiring stories like that because it really is needed. Like, it's time to move beyond this top-down control of everything biological and medical. Your DNA is yours. Your health is yours. What about crowdfunding of medical research? Do you see applications for blockchain technologies or Bitcoin in that?
I do. I mean, that's effectively what we're doing right now. And of course, we don't know what the answer is going to be, if it's going to work and people are going to contribute. But I think as the Bitcoin community gets bigger and bigger and more people are using it, I think they'll recognize that if you want to be, provide generosity, this is the way to do it. The ALS funding was great. But if you go through and actually look at how much overhead they have, people start to question that. I mean,
that's basically what put the ice on the ice bucket challenge.
$600,000 salaries, or I don't know what they were, but they were large. They were larger than what many people might make, even in the private sector. I think with Bitcoins or blockchains, for that matter, you can much more transparently redirect funding to a given problem than perhaps setting up a brick and mortar 501(c) that has an HR specialist to avoid the threat of the state from the HR violations, and another lawyer that helps you make sure that you're not doing the wrong tax thing. I mean, there's just all of this overhead that gets incorporated into a business to do even charitable work that even the charities end up having high overhead.
This episode is brought to you by CryptoKit.com, the easiest, fastest way to spend Bitcoins right from your browser. Today's magic word is viral. That's viral. V-I-R-A-L. Viral. You've got until the 1st of November to visit letstalkbitcoin.com or the Let's Talk Bitcoin iPhone app and enter it for your share of the listener rewards. Let's rejoin Kevin and Stephanie.
Just in the last couple of years, we're seeing the rise of biological hackerspaces where people are actually doing their own laboratory research or basic biomedical research, not with like dangerous pathogens or anything like that, but they're basically just playing with DNA and trying to figure things out and making little DNA constructs and things like that. And they're doing it in not academic institutions, but in hackerspaces. And that was unheard of basically for most of my life before the last couple of years. And I just think it's really cool. And there are lots of problems with government funding of science. Oh my gosh, you could speak to this too, but academic researchers are really nice and kind, but they just don't have the correct incentives sometimes to do useful, helpful research. It becomes more about chasing grant money from the government and trying to please the overseers at the NIH so you can get more grants in the future. And it really kind of corrupts the process of science, and it alters the incentives so that it's not as good as it could be. And that was something that I found really dismaying about academic science.
There's a lot of interesting stories on this as well. And it's very true. The incentives there do not promote out-of-the-box thinking. The peer review system almost forces you to incrementalism off of your advisor. It's very difficult for you to launch off into a new place because you'll get ridiculed by anyone trying to review it. But we saw some of this actually in the funding of the Human Genome Project and on the next generation sequencers. If you actually take a look, despite, I know many of these people, and they work really hard and they're really fun to work with. And yes, they're in the government and they're not stupid. They're actually really intelligent, but they're just in an infrastructure that clogs things and doesn't necessarily have all of the market information that it needs. But they funded a tremendous amount of next generation sequencers. And you will see a lot of propaganda that the government created that wave of technology. But actually, if you look closely at the data, what you'll see is that the amount of government funding pretty much predicted your death in the technology race. In fact, if you look at government funding into the next generation sequencing space, it's inversely correlated market share. So Illumina arguably now owns the space, and they got the least amount of government funding. And you can go down every other technology and look at how much government funding did they get and what percent of the market do they have. And it's like an R-square of like 95. It's incredible to the correlation. And everyone's always asking me, how can that be? You think you stuff free money into a bunch of companies. Wouldn't that mean that you're pushing and creating a balloon in that type of market? And there is some random success with balloons, but what's really happening there is the researchers are listening to the grant goals, which get reviewed every 2 or 3 years. And the people who don't have them are listening to the customers that are yelling at them quarterly. and so the people who are listening to customers are making things that people want to buy. And so they survive longer. And I experienced this like throughout that entire wave. I think we ended up with about 35% of the market with the sequencer that we built. But we, quickly got derailed into dealing with a variety of things with the government. And we also just were a little bit late to market, and there's other forces that pushed us out. You can look through the companies from PacBio to the Solid Sequencer to Helicos to Illumina to Complete Genomics. Go down this list. There's a clear pattern there, an amount of government funding in their place in the market, and no one wants to talk about it.
That's another thing. It's this government money that flows into not only academic science, but also scientific companies. Like, yes, companies are getting grants from the government to do scientific research, and it really changes incentives for them. And one of the results of that is that they're not willing to bite the hand that feeds them. They're not willing to criticize the government. And actually, there's this culture of just loving the government, but also being mad at them for not giving enough funding. It's really weird.
Yeah, it's happening right now with this whole Ebola virus thing. And that I think a few months ago, for the last few years, I've been somewhat annoying my friends talking about free markets, and they used to call me anarcranky. And and so, when Ebola pops up, they're like, see, this is why we need it. It's not about roads. It's about Ebola funding. And I just kind of sat back saying, okay, we'll see how that plays out. But I'm not holding my breath for there to be, great things done by the CDC. And of course, this week, it's those same people who are furious about the fact that they let people on planes and on boats. It's like, no, the problem isn't the CDC, and it's not the researchers. They're smart, intelligent, and working hard. The problem is between your two ears, that you believe that this might work. We need other mechanisms of bringing individuals and market forces to play here. And that's what's going to solve this.
The incentive to make a profit, which in order to do that, you have to make something that people want or people need and they're willing to support your company for, is just so different than the incentive to kind of get more grants from the government and to please a few specific people and not have that profit motive. It's just two different worlds.
Oh, yeah. The argument I've gotten from many of them is market failure, right? You need the government to do this because no one else will do Ebola research. Or in the case of the next generation sequencers, they were claiming we needed government to do this because of market failure. But we applied for one of those grants, and we were awarded a $6 million grant from the government to build our sequencer. But it took us about $1 million just to apply for it. And who paid for that application? It was a private company that apparently was too risk averse to invest in a grant application.
Wow.
So the argument of market failure, whenever anyone brings that up, they're not recognizing that applying for government grants takes an enormous amount of money. So someone's funding that application, and it's the private sector. They're happy to take the money when the government gives it to them, but it's not an actual reflection of market failure.
When I see breast cancer researchers trying to get grants from the Department of Defense,
Does that happen?
Oh, yeah. Oh, so many times, Kevin. Like, I saw people who were doing research on visual neuroscience about how the brain recognizes shapes and objects, approach the military for funding, because what happens is, like, the National Institutes of Health cuts down their budgets for funding science. And so the only thing that's not getting cut is Department of Defense and the War Department, we should call it. And so the scientists go to the War Department and ask for money for their research, and then they end up shifting their research to please the military-industrial complex so that they can get these grants. The research that they're doing changes because of who they're being funded by. They also have this chilling effect on what they're willing to say or the conclusions of their research, because it can't be critical of the military or of drone technology or of whatever, because that's biting the hand that feeds them. So scientists always have to declare conflicts of interest when they write a manuscript for scientific publication. But like the ultimate conflict of interest is being funded by the government or by the War Department, by a specific branch of the government that you then can't criticize and can't come up with conclusions that are critical of them, or you're going to lose your funding.
And the irony of it all is it's done in the name of the private sector being full of greed.
Exactly.
The funding coming through them is, actually extorted through individuals who have no choice in the matter. And that's fundamentally what's wrong is they don't have microenvironments, and they don't have an understanding of feedback mechanisms that you might see in something like Leonard Reed's, iPencil, where that feedback mechanism is broken when it comes to government representation. And blockchains have a chance to change that as well. As long as they're voluntary, I'm good with that. But right now, this voting every 4 years and they represent you in some way is all seems. I'm hoping this is a myth that's soon going to burst in everybody, that they realize this can't be true. We can't be voting every 4 years with technology that was invented before the postal stamp. And and yet they can, put missiles apparently down chimneys in foreign countries with drones driven out of Utah. That same organization can't figure out the hanging Chad. I mean, they don't want to listen to you unless it's on their terms. And that's not a form of representation that's ever going to solve a disease. It has completely different motivations to actually sell fear. And fear is the ultimate parasite that they can chew on. And I think the whole topic around Ebola virus is which virus is going to win. The mental virus of fear that the government sells, I think that's very dangerous. With now we've got 4,000 troops going to Africa, or the actual virus.
Yeah, not 4,000 doctors, 4,000 military troops going to Africa to fight Ebola. Like, how are they possibly going to do that? Aside from killing everyone, I mean that's the only solution they have, because when you have a hammer, everything looks like a nail, man. It's really tragic. Those nanometer particles you can actually shoot, I'm sure. Yeah, it's upside down. But the promising end of this, I think, is that the research that you'll see on this website that's coming out is a virus is mutating very quickly, and everyone's panicking about that sort of supports the airborne hypothesis. But it's a double-edged sword for the virus, in that any virus that mutates that quickly means that it's very sloppy with the enzyme it uses to copy DNA. And we can poison that with molecules that our DNA has very high fidelity, probably one mistake in 10 million or higher. So it doesn't put in nucleotides or bases in the DNA that are terminators. It's very good at rejecting those, but the virus puts in anything. And so we can use the whole pharmacopoeia that was used in HIV with AZT and acyclovir, and all of these molecules are based on the premise that the polymerase is so sloppy that it can put in a base that terminates the progression of the enzyme and poison the replication. And I think we're already starting to see some companies that have drugs. BCX, I think, is one of them, that has a drug called BCX 4430 that's mentioned on that site that is a really strong, it's showing some promise in terminating filoviruses. There's also some Niemann-Pick small molecule inhibitors. I think the small molecule path is the direction you got to go. This concept of a vaccine is very difficult to conceive that they can get one that's going to work for a virus that's changing this quickly. It's almost like the flu. We need a new one every year. Yeah, and how would they possibly test the safety of that vaccine either in a short period of time? I mean, I agree with you that the strategy of using drugs that are already available and already have known safety profiles and so forth is a way better strategy.
And those you actually target to a smaller population. I mean, vaccines need to go to everybody. Right now, there's maybe 10,000 people that are at risk that should all have access to maybe some of these small molecules of choice. And then in the meantime, if we can slow it down with that, we need to be sequencing to understand, I think, the virus's mutation rate, and we need to be sequencing the resistance genes in the population to see if we can better predict the spread of this. That's what our thing's meant to do. We're hoping to get money to those people and do it in a transparent way. It is an experiment. We don't know what the market's going to do, but part of that is why we're excited about it.
Speaking of HIV, back in the 80s, when the government and the pharmaceutical companies didn't want to listen to the people who were dying and keeling over of HIV, there were black market chemists who were synthesizing AZT, which was the first prototypical drug for HIV, like in their basements and things like that. And it was like they were just trying to get help to the people who were really suffering from this disease, because nobody else would care about them or listen to them, probably because they were gay, but also because they're marginalized, They had to kind of turn to these illegal but life-saving types of
it's happening today. Yeah, this whole Dallas Buyers Club is now Denver. It's this epilepsy drug that is found in the cannabis plant, and people are lifting up and moving to Denver to get access to cannabidiol, and we're in the middle of this whole storm.
For epilepsy.
For epilepsy, yeah, we're sequencing for people who are doing it and who are trying to run through this in Colorado. It's actually in clinicaltrials.gov, but it's a very interesting project to genetically stratify the patients that are responding and the patients who aren't responding to see if there's a signature there, so that we can try and predict who should move and who shouldn't, and also just to better inform the pharmacodynamics of this drug. We don't really know why this drug is working. It's amazing what it's doing. It's probably the best thing epilepsy's ever seen.
So for some people with epilepsy, they are benefited by cannabidiol, which is a chemical that's in the plant that many people know as cannabis or marijuana.
Yeah, and it is a miracle drug. And it's not me saying that. You can go and hear the lead epileptologist now talking about this. A third of kids with epilepsy are drug resistant, and they're just cycle through 15 to 20 different drugs to try and find a solution. But their seizure rate increments to the point where they get SUDEP, which is sudden unexplained death from epilepsy. It's a horrible thing for these families. And they're at their wits' end. So this drug in a plant is showing about a 20% rate of complete seizure freedom. And the next thing closest to it was like gabapentin, which has like a less than a 1% seizure freedom for these types of kids. So it's an absolute miracle for these people. There is a pharmaceutical company trying to bring this out under the label of Epidiolex. They're called GW Pharma, and there's some trials going, and we're sequencing some of those patients as well. We're not picking sides on sort of the FDA versus the dispensary direction that this goes, because when we saw that movie Dallas Buyers Club, the moment those two markets get polarized, it kills the patients. There was just a black market against the FDA, and it turned into a real mess. And so we're trying to bring them together and be like, guys, it's all pre-competitive data. Let's sequence both groups and see if we can make sense out of this, and not turn this into an assumption that this market is small. This market's probably much bigger than either of you guys realize, and just let it grow and see what happens. That's the same story. It's repeating again. And it's like we just don't learn from history.
No, we really don't, despite how much we might be shouting from the rooftops about history. I don't know if you want to talk about this on the show, Kevin, but I think you were also involved in a project to do some kind of crowdfunding with basically a cause coin for epilepsy research on cannabinoids and how they could benefit epileptic patients at like a music festival. Was that right?
Yeah, so we're trying to get a sort of like a music event, a 420 event going that can help get some of the recreational interest that's happening in Colorado and soon probably Nevada and also in Washington to help drive funding to CBD research. Because we want to understand how this drug works. And the plant also makes like 85 other cannabinoids. There's probably a good dozen that are hot targets right now for a variety of diseases. The funding in the States for this is really hard to manage. To give you some examples, the folks who are running the FDA-based trial for Epidiolex, they've got to put in like 2,000-pound safes that have multiple cameras watching it so that no one runs off with a non-psychoactive cannabinoid. And that all takes time, right? You have to file.
Is that all because it's considered by the federal government a controlled substance? It is. The compounds that this weed of a plant produces.
Yes, and it's not psychoactive either, but just since it comes from the same plant, they've basically said the entire pharmaceutical repertoire of that plant is the devil, and it's all class 1 or schedule 1. And so all of these other most of the cannabinoids in the plant aren't psychoactive, and they're all incredibly therapeutic for different things. You have to be careful what you use them for, but there's not a whole lot of toxicity that's ever been shown out of any of them. And so in order for these folks to get this trial going, they had to go through all the hoops of getting DA licenses and cameras. And the place in MGH, the floor wouldn't hold the safe. So they had to put it like in the psych ward in the basement and then put in key cards for everyone to travel to and from the trial. It's just one of these things that's like, wow.
That's ridiculous.
But you look at the dispensary side of this, and it's much more free market, and it might win just because it has thousands of things blooming, no pun intended. There's just a lot of different innovation that's occurring. And many people are crying out that that's too scary and too dangerous, and it comes from the same people that have no understanding that alcohol is like 100 times more poisonous.
Tell the story of how you had to get the DNA to sequence the cannabis, indica, and sativa genomes at Medicinal Genomics.
Yeah, so I was probably a little paranoid those days based on, that was a time in 2011.
Paranoid?
Yeah. I've probably got only more paranoid, right? But back then, the Obama administration kind of fake left and went right. They kind of claimed that they weren't going to pay any attention to that, and then they suddenly start cracking down harder than Bush.
Yeah.
And right as that happened, I realized I got better talk to an attorney about this. So I ended up not wanting to touch any of the material here in the States. Even though in Massachusetts, I think under an ounce is like decriminalized or something, it's still federally legal. And when you're dealing with science and DNA, you don't need ounces, you need micrograms, like millions of a gram. We touch very small amounts of it. But I ended up designing a DNA purification system in my garage that could handle plant matter. And I had to figure out how to get it into a suitcase that I could get through the TSA, which isn't easy because Holland doesn't like to receive centrifuges. Like centrifuges are considered, bad. And of course, even if it's a tiny desktop centrifuge that can barely spin a microtiter tube, or they see centrifuge on it and they think you're doing uranium. All of those things we had to think through. So we opted to use like magnetic particles that could do the same thing, but didn't require centrifuges. I think the recipe required a coffee pot that could get water to 65 degrees C, because that's the lysing temperature for most plant matter. Mm-hmm. Soaps that we could get, like SDS or in a lot of shampoos. Ethanol, which we could get from Everclear anywhere in Holland. And magnetic particles and a magnet plate and a positive pressure pipetting system. So yeah, we purified 10 strains in a hotel room in Holland and brought the DNA back because the DNA
using just kitchen equipment. It's incredible.
Yeah. It wasn't the cleanest DNA, but the genome sequenced. Now it's probably much easier to get that kind of work done. But our attorneys are basically like, take this offshore. There's too much confusion here in the States between federal and state laws that we don't know how to guide you, and you're better off just going to Holland and getting the DNA. And from what we can read right now in the law, DNA can move across lines. DNA is considered a hemp biopolymer, and it's not considered to be illegal because there's no THC. And we've proven that our DNA preps have no THC in them. So we have that kind of HPLC data. But that's what it's like trying to do research in that space. Wow. And so we need to find ways to get funding to that important type of research that aren't complicated by all this federal overhang. Like the research they're trying to get done in Denver, in Colorado, it's very difficult for the hospitals to sign on to it because their federal funding can get pulled. So they have their claws into this from multiple different angles. Everywhere you turn, you think you've got a route to go, and the next thing you hear from the dean that, sorry, we can't support that research here because it puts $6 million of government funding we're expecting at risk.
Even though it could help, potentially, you don't know how many people it could potentially benefit or help.
In some ways, I hope it all goes over the counter and it ends up in a dispensary model, only because I think that they're very safe compounds. All of them are very, very safe. The most dangerous thing about it is how people extract them. If they leave hexane and other chemicals around, that can be a problem. But other than that, it is going to be a revolution for medicine, I think, because if you have that much pharmaceutical repertoire that's all very high in their therapeutic index, meaning the ratio of the effective dose to the lethal dose is very large, you effectively have an open source pharmacy that's going to be over the counter soon. That combined with personalized medicine can solve an enormous array of diseases that are right now being addressed with chronic drugs that don't necessarily target the right disease.
Well, they might soon be addressed with chronic drugs.
Yeah. Good play. Yeah.
Oh, God, the puns are just so bad in any article you read about pot. Everything is up in smoke or joint or blunt or anything.
Yes, yeah. A joint venture to
yeah.
pot of gold.
Well, that's so cool to hear about, Kevin. I really appreciate you sharing these stories. It's just fascinating to talk to you. And I feel really hopeful about the future of science, knowing that there are people like you out there. So thank you for doing what you do.
Oh, thank you. Big honor. I appreciate it. Thank you for letting us share this story. And if anyone is interested in taking an individual stance against the fears of Ebola virus, please help us. Feel free to comment and give us information that we're missing on the website.
Yeah, and I'd like to just tell people what your website is. It's medicinalgenomics.com. And right up at the top on the header, there's a section that says Niemann-Pick type C and Ebola virus. Just click on that and you can find all the information about this open source fundraiser and find the Bitcoin addresses to donate to that too.
Yes, indeed.
Your other websites, or how do people get in touch with you?
Thank you for offering that. So our efforts here are meant to just redirect money. Cortigen shouldn't receive any of this. What we do is we tend to be sequencing patients with epilepsy, mitochondrial disease, or autism. If you know of anyone that has sort of an underdiagnosed or is on some type of diagnostic odyssey related to that, contact us. We'll connect you to physicians that are well informed on using DNA sequencing to help better inform the drug management there. That's all done through Corrigan Life Sciences. They own Medicinal Genomics. We're just a subsidiary. And then the other thing that we're working on that should be released shortly, we're taking some of this knowledge that we have about the cannabis plant and designing methods to detect mold and bacteria on the plant. This is something that's probably the most, if there are any deaths ever attributed to cannabis, it's not from the plant, it's from the mold that grows on it and people inhaling it. So Aspergillus infections in immunocompromised patients have actually created a couple deaths in some patients. And so some states are mandating that mold and bacteria testing be done in every plant. They did not come up with that. That was actually put into place by free market mechanisms in California that doesn't have these regs. You'll see some testing companies like Steep Hill Labs out there just decide to do this on their own. And as a result, it's been emulated into many of the legislations in Colorado and in Washington and in Massachusetts. And that it's traditionally done with plating bacteria on cells and waiting days for them to grow to count them. And we can now do this with DNA. We can do quantitative PCR and pick this up in an hour, speed it up, make it cheaper, bring more safety to the field. So those are really the two areas that the company's focused.
Who does the testing? Is that Medicinal Genomics? Or is
Medicinal Genomics. We don't handle any of the testing ourselves. We sell picks and shovels to the companies that do.
Got it.
That's a quantitative PCR system that detects E. coli, salmonella, yeast and mold, and a variety of other organisms.
Okay, and then Courtagen is Courtagen, and that is for genomic sequencing for maybe children with rare diseases or people who are trying to diagnose mysterious diseases.
Yes, indeed. And we have a particular focus on cannabidiol lately with all the epilepsy work that we do.
Kevin, thank you so much. It's just been a real joy to talk to you. I'm just so glad you could make an appearance on Let's Talk Bitcoin, and keep on doing what you're doing. You're just awesome.
Oh, thank you. Very much appreciate the time. Keep going with the podcast. I love them.
Thanks for listening to episode 158 of Let's Talk Bitcoin. Content for today's episode was provided by Stephanie Murphy and Kevin McKernan. Music for today's show was provided by Jared Rubens and General Fuzz. This episode was edited by Adam B. Levine. See you next time.